point 2 has to do with slopes and intercepts, which will get us to slope-intercept form. Ha ha ha. Okay, so what is slope? Anybody? Oh, come on. Someone in this room knows what slope is. Rise over run, right?
Yes.
Your rate of change is the same thing as your slope. Change of y over change of x. Have you guys seen the symbols delta y, delta x for change, right? Okay. And you guys have Mr. Hannon freshman year? Is he still here your freshman year? I think he was. He gave us, he gave all the math teachers after he left these guitar picks with a delta symbol on it to say, you know, take on the change. I don't know. Be the change. Anyways, so remember we use the lowercase m to represent slope.
I don't understand that.
It has to do with, I think, either the Latin word for slope might start with an M, something like that. Anybody in Latin?
It's mantigrees.
Is that what it is? Say it again.
Mantigrees?
Mantigrees. So there we go.
I made that up.
That is not it.
Wait, what? It sounded legit.
I was going with it, Avery. You should just kept it, and then I would have. From this point on, I would have taught every single one of my classes mantigrees. Mantigrees is Latin word for slope. No, not really.
What did you just say? Mantigrees.
Yeah. All right, so remember that your slope is rise over run. So remember, rise is your change in your y. Run is the change in your x. And it has to be, and I'm writing in the corresponding change in x because it has to match up with the change in the y. It can't just be any change in x. Okay? What's the formula? That's slope-intercept form. What's the formula for slope? Yeah, you subtract your y's over subtract your x's, right? So y sub 2 minus y sub 1 all over x sub 2 minus x sub 1. All right, so if I give you 2 points, can you find the slope of them without graphing?
Maybe.
Maybe. Here we go. Your 2 points are 0, 4, 3, 1. See if you can beat me to the punchline. If I needed to find the slope between those points, hopefully we're at the point where we don't need to label anymore, but I will do it just for instructional purposes. If we have x1, y1, because that's my first point, and those are the x and the y coordinates, in point 2 I would have x sub 2, y sub 2. So subtract your y's, subtract your x's, make them into a fraction. 1 minus 4. Would it be incorrect to do 4 minus 1? No. But I need to make sure that the corresponding x's align. So if I'm doing 1 minus 4, what does my denominator need to have for a difference? 3 minus 0, because the 3 and the 1 correspond together, and the 0 and the 4 correspond together. So I need the 1 and the 3 to be aligned, 4 and the 0. If I did 4 minus 1, then what would be in my denominator? Yeah, 0 minus 3. So what do we get? Negative 3 over 3, which is negative 1. So your slope for those points would be negative 1. Did you get there? Yes. Never, ever, ever. Students do this. They write their slope as an ordered pair for some reason. I don't know why. Slope's not an ordered pair. It's a number. Okay? So they would do like negative 1 comma 1 for the denominator. Okay, so we got slope taken care of. The intercepts. Remember, you have intercepts of a graph. We're going to be talking about both the y and the x-intercept. So remember that the y-intercept is going to be the y-coordinate. Coordinate is a number. Just talked about the good old ruler postulate in geometry today. You guys remember all the way back to Chapter 1, Section 2 geometry from last year? So the y-intercept is the y-coordinate of the point where the graph of a linear equation crosses the y-axis. So if I'm asking you for a y-intercept, I'm not looking for a coordinate point. I'm just looking for one number. The y-intercept is 4. The y-intercept is -4. Does everybody envision where a y-intercept of 4 would be on a graph? Yes, right? So the y-intercept of +4 would be here. Y-intercept of -4 would be down there. So what do you think an x-intercept would be? What are we going to change from that definition? Change all the y's to x's. Yes. So the x-intercept is going to be the x-coordinate of the point where the graph of a linear equation crosses the x-axis. I just need to get rid of this marker. It's not even good. Okay. So your x-intercept of 2 would be here. An x-intercept of -3 would be here. Now let's think about real-world examples. Why would it be beneficial to know x and y intercepts? Because if you think about it, everything in the real world is visual. I mean, we do a lot of math, we do a lot of number representations, but if you apply it to the real world, visual representations of mathematics is what's the most important part. You guys hate graphing. Everyone hates graphing. But honestly, graphs are the closest thing that's going to relate to something that's out there in the real world. So let's say I had 1, 2, 3, 4, 5, 6, 7, 8. We'll call it 800. This is 100. Are there 1, 2, 3, 4, 5? What's my y-intercept? 800. What's my x-intercept? 5. If I was thinking about this in a real-world context, can someone give me a story about that graph?
I'm not creative at all.
Well, let's think about the x being time. Usually x represents time. So how many hours are we dealing with for something to happen? Okay. What's happening?
It's going down. They're losing money.
They're losing money, okay. I was thinking maybe Cole gets 800 hamburgers put in front of him, and it takes him 5 hours to eat all of them to get to 0. That was my story I was thinking in my head. Or you start with $800 at a shopping mall, and it takes you 5 hours to spend it all, right? 800 hamburgers, that would be quite a lot. Okay? So x and y intercepts are really important in real-world applications because that gives you a beginning and an ending point. If you think about it graphically, okay, if we're just in the first quadrant. Okay, so that's why it's important to recognize what x and y intercepts are. Okay, so can we graph? Let's see if you can do this. Make a nice quick coordinate grid on your notes. Yeah, do all 4 quadrants. Go out 5 units in all directions. And can you make a graph of a linear equation that has a y-intercept of 2 and an x-intercept of -3? What would that look like? Y-intercept of +2, x-intercept of -3. So we should be putting a dot where on our y-axis? That's at 2, right? And x-intercept is at -3. Your graph should look like the following, hopefully. Close enough. Just a rule of thumb for graphing, because I know all the math teachers are different about it. If for homework, I know I don't personally use graph paper that often. If you need the graph paper to make your graphs, that's fine, use the graph paper. But if you want to just make like lazy coordinate grids like I'm doing here, that's fine also. Just make sure you put the units on. I've had students before who would just go like this. Oops, that's not even at a y-intercept. They say, hey, there's my graph. I have no idea what those points are. They're just on there. I get the idea that you know what a y-intercept and an x-intercept is, but do you really know what you're doing? Okay? So be a little bit good about your lazy graphing. If there's something where you need to do a word problem and make a graph, you're probably better off using a piece of graph paper because you're probably going to need to extend your line and make sure everything matches up. Okay? All right, so we got x and y intercepts down. So we talked about slope. We talked about intercepts, which leads us nicely into slope intercept form. What is our slope-intercept form? Y equals mx plus b. What does the m represent? Slope, good. What does your b represent? Y-intercept. Why do you think they care about the y-intercept and not the x-intercept? Are they being discriminatory?
Yeah.
Yeah, they are. They're not caring about that x-intercept. Why do you think they care about the y-intercept?
Starting point.
Usually that's how you go to graph. It is your starting point. That is correct. Let's think about this. If I gave you the equation, don't put this in your notes, just watch. If I gave you the equation y equals 5x plus 1, would it be easier to evaluate that or solve it if I gave you the x value? If I said x equals 1, what's y going to equal? 6, right? If I say x equals 20, what does y equal? 101. That's pretty easy to evaluate, right? If I said y is equal to 101, is it easier to solve for x? No, because you're going to have to do a little bit more work, right? You would have to subtract 1, then divide by 5 to get to x. So which is the dependent and the independent variable? Does the x value depend on whatever the y value is? Or does the y value depend on whatever the x value is? The latter that I said, right? So your y depends on x, which makes x independent or dependent? Independent, because it doesn't matter what you plug in for x. You can put whatever you want in for x, and then the y will be changed by whatever that x value is. So because the x can be whatever it wants to be, the y is a bit more of the unknown, so that's why we're focusing on that y-intercept. Okay? So, slope-intercept form. We've got that taken care of. If I give you an equation, can we turn it into slope-intercept form and then graph it? Hopefully. If I have negative 2x plus y equals negative 3, what does that look like in slope-intercept form? Hannah? Good. Yeah, and the way that I do it, I just kind of draw an arrow to say that I'm moving it over. When I move it over, it changes signs. So my negative 2x becomes a positive 2x, and then it becomes a minus 3. So where's our starting point? Yeah. So I'm going to make a lazy graph. Go down to negative 3. What's my slope telling me to do? Up 2 over 1. Up 2 over 1. You want to go up 2 over 1 again? You can. How would I go backwards? Down 2 to the left 1, right? And then as best you can, try to go through all your points. So, can we find the slope between 2 points? Yes. Can we identify x and y intercepts and graph them? Hopefully, yes. Can we change something into slope-intercept form and then get the graph of it? Yes. Can we do the reverse? If I give you a graph, can you give me the equation?
Yeah.
Okay, you don't have to put this in your notes. What would be the y-intercept?
2.
2. What's the slope?
2. 2 points.
Yeah, positive or negative?
Negative.
Negative 2/3 x. Good. Okay, so we would have negative 2/3 x plus 2. Okay. All right. What does standard form look like? We already wrote something in standard form in our notes. That's point slope form, Sarah. You're at point slope. Yes, Hannah's on to something. Standard form is just like point slope form, not point slope form, slope intercept form, but the x term is on the other side. So if I had y equals 5x plus 6, and if we move this over to the other side, then that takes me back to standard form. So 2 examples ago, we had it already written in standard form. All textbooks use this as their form, not ax, what am I doing? Ax plus by equals c, where a, b, and c are some number, is your standard form. So all you really need to be concerned about with standard form is that your x and your y terms are on the same side. Some key factors: you can't have a negative x term. So you can't have a negative x term. So for example, if I had negative 2x plus y equals 6, what could I do to all those numbers so that my x term is no longer negative? Yeah, multiply by a negative 1, or just change all your signs. So that would turn into 2x minus y equals negative 6. So now my x term is positive. My y term can be negative, that's okay, but your x term cannot be negative. So you can't have a negative x term, and you also can't have fractions. So fractions are not our friends in this case. We want to get rid of them. So if I had something like this, if I had 1/5 x plus y equals 3, what number could I multiply everything by to get rid of the fraction? Yeah, 5. X plus 5y equals 15 would get you there. Okay, so that's the thing with standard form. You can't have a negative x term, and you can't have fractions. The only thing we're going to get out of standard form today is to identify the x and the y intercepts. We're not going to go into the solving until the next few sections. So if I have something in standard form, do you guys remember how to find the x and y intercepts from it? Think about your x and y intercepts. What are the coordinates of this x-intercept? Negative 3, 0. Good. What are the coordinates of this x or the y-intercept? 0, 4. So for an x-intercept, which coordinate, the x or the y, is 0? The x or the y is 0 in in the x coordinate. The y is 0. In a y coordinate, what is the 0? The x. So do you guys remember the cover-up method? Just cover it up. What would be my y-intercept? What would y equal if I got rid of the x? Well, it would be 3, right? 5 times 3 would be, you were there. What would my x-intercept be? 15, right? Do you guys remember doing that in Algebra 1? So let's go ahead and do an example. If I give you the equation 2x minus 3y equals 6, which is in standard form, and I wanted to find the x and the y intercepts in order to be able to graph it, I could put that in slope-intercept form and then graph it. Question? Yeah.
Do you cover up? I forget if you cover up the negative before a number.
No, you don't.
You don't.
That
Okay.
gets included. Okay, so what do you want to find first? X or y? Go. X. Okay, here, x first. So x-intercept. So to find the x-intercept, am I going to get rid of the x or the y? I'm going to get rid of the y because I want the x, right? So I'm going to have 2x minus 3y equals 6. I'm going to get rid of the y term. So what does x equal? 3. So my x-intercept is 3. I guess I shouldn't write it like that. My x-intercept is not equal to 3. It is 3. I want to make it look like a solution. Okay. Y-intercept. What am I going to get rid of? The x. So the 2x minus 3y equals 6. You do, like Hannah asked, you want to carry that negative sign with the y term. Remember, subtract is the same thing as a negative. So what's my y-intercept going to be? Yeah, so we get negative 2. So my y-int is negative 2. Can you graph them? Sure. Lazy graph. X-intercept at 3. Y-intercept at negative 2. Connect. Let's put a story behind it. What's happening?
You start with like $2 in debt.
And it takes how long to get to a 0 balance? You're going to go 3 hours? Sure. Okay. I was thinking there's a gopher that dug himself a hole 2 feet under the ground. And then, I don't know, took 3 days to get out of that hole? I don't think so. Took him 3 minutes to get out of the hole. That might be a little bit more realistic. All right. So x and y intercepts. The last thing we need to cover is horizontal and vertical lines. Do you remember the equations for horizontal and vertical lines?
X equals something.
X equals something and y equals something, yeah.
I don't know.
So for your vertical, this is honestly the last slide. For your horizontal and vertical lines, you have to remember which is the horizontal and which is the vertical. So let's think about this. If I drew a horizontal line, does this horizontal line ever have an x-intercept? No. So it's going to be the one with the y, because your y is always equal to, here I'm at 0, 2, here I'm at 1, 2, here I'm at 2, 2, here I'm at negative 1, 2, so my y is continually going to be 2. So if it's a y equals equation, that's going to be horizontal. So this is horizontal. What I like to think of this as my intercept. It's telling me I have a y-intercept at negative 2. Well, if I put negative 2, if I put a y-intercept at negative 2, would I draw a vertical line through it or a horizontal line through it? Horizontal. If I drew a vertical line, that would be the same as y equals negative 1. That would be the same as y equals 0. That would be the same as y equals 1. So it's going to be horizontal. If you have an x equation, think of it as an x-intercept. So that would be -3. If I drew a horizontal line, well, that would just go along the axis. That's not what I want. So it would be a vertical line going down. Okay? All right. I don't think we're going to have time to do bingo because it'll